Good afternoon, everyone. Today we'll be exploring the fundamentals of database management systems or DBMS. This session will cover the key components and functions of DBMS as well as its role in managing large volumes of data efficiently and securely. So, what is a DBMS? A database management system is software that helps manage databases by providing an interface to users and applications for creating, retrieving, updating, and managing data. A database management system is a software that is designed to handle the storage, retrieval, and manipulation of data in a structured way. The main purpose of DBMS is to ensure that data is stored in an efficient, reliable, and secure manner. The core functions of a DBMS include storing data, retrieving data through queries, and manipulating data by adding, deleting, or modifying records. DBMS also ensures data integrity, security, and proper backup and recovery mechanisms. Let's break down the main functions of a DBMS. First one is the data storage. DBMS stores data in an organized way, usually in tables. This makes it easy to access and manage large amounts of data. Data retrieval. Using queries such as SQL, structured query language, users can search for specific records or information from the database. Then data manipulation. DBMS allows users to add new records, update existing ones, or delete records as needed. This manipulation is done dynamically through data manipulation language (DML) commands. Then transaction management. DBMS ensures that transactions are completed successfully, maintaining the integrity of the data even in the event of failures. Then coming to the components of a database management system, DBMS consists of several key components that work together to perform database operations. Database engine. This is the core component that manages data storage and retrieval. It ensures that data is correctly stored and accessed. And then database schema. The schema defines the structure of the database, including how data is organized into tables and relationships between those tables. Then query processor. The query processor interprets SQL queries and converts them into a form that the DBMS can understand and execute. Then transaction manager ensures that database transactions are processed reliably and that the integrity of the database is maintained. Then database dictionary. This is a repository that stores metadata about the database such as table structures and relationships. Metadata is data about data. Then database engine. The database engine is the heart of the DBMS. It handles the actual storage and retrieval of data. There are different types of database engines. First one is a relational database engine. It is used in relational DBMS like MySQL and SQL Server. Data is stored in tables with rows and columns. Then a second is NoSQL engine, used in NoSQL databases like MongoDB. It stores data in different formats such as key value pairs or documents, making it suitable for handling unstructured data. Then data definition language DDL. Data definition language is used to define and manage the database schema. It allows you to create, alter, and delete database structures like tables and views. Some common DDL commands include create, alter, and drop. Create command is used to create a new database objects such as tables, views, or schemas. Alter modifies an existing database object like adding a column to a table, and drop removes database objects such as tables or views. DDL commands are used to set up and modify the structure of the database. And then coming to the data manipulation language DML. Data manipulation language is used to interact with the data stored in the database. It includes commands for retrieving, inserting, updating, and deleting data. The key data manipulation Language commands are select, insert, update, and delete. Select retrieves data from the database, often with conditions. Insert adds new records to a table. Update modifies existing records. Delete removes records from a table. DML commands allow us to dynamically interact with the database and manipulate the data stored in it. Then data dictionary. The data dictionary is an essential part of DBMS. It stores metadata, which is data about the database structure. The data dictionary holds information about the tables, fields, data types, constraints, and relationships within the database. It helps ensure data integrity by defining the structure and roles that govern the database. The data dictionary is also used to track user permissions and access controls. Then database models. DBMS comes in different types based on how data is organized. First is the relational model. Data is stored in tables with rows and columns, for example, MySQL and SQL Server. Then second is hierarchical model. Data is organized in a tree-like structure similar to a file system. Then there is network model. Data is represented in a graph structure where records are linked in multiple ways. And then object-oriented model. In this, data is represented as objects, much like in object-oriented programming languages. Then advantages of DBMS. DBMS provides several advantages. The first one is data redundancy control. Reduces the duplication of data by centralizing storage and ensuring that the same data isn't stored in multiple locations. Data integrity. It ensures the accuracy and consistency of the data by applying constraints like primary key keys and foreign keys. Data security. Protects data from unauthorized access by defining roles and permissions. Concurrency control manages simultaneous access to data by multiple users, preventing conflicts and ensuring consistency. Then backup and recovery. DBMS has built-in mechanisms for backing up data and recovering it in case of a failure. So in conclusion, DBMS is essential for efficiently managing large data sets. It allows data to be stored, retrieved, and manipulated in a structured way. By utilizing components like the database engine, DDL, DML, and data dictionary, DBMS ensures that the data is secure, consistent, and reliable. Understanding DBMS is fundamental to working with databases and helps provide a foundation for learning database management and design. Thank you.